Oh, how did that happen? So I thought I lost our keyboard, but he's still on, and randomly we started the show. Now I wanna talk about. Let's dip in the Let's go watch. Okay, I wanted to say go read the paper, but now I'm gonna watch. Yeah, I'm gonna read the fucking paper. Yeah, let's read the paper. This time we are going to read the paper like a scientist. We act like a curious scientist. That's what we wanna do. Where was the paper though? So we have the knowledge distillation and counterfactual, and counterfactual learning to rank via knowledge distillation. That's one paper. Like 20 pages. And also I have another paper Ehsan sent me today. Actually, I don't know if I can share it with you or not. Yeah, I think I cannot share this one with you. Oh my god, I love this paper. This paper is so pretty. I wish one day we can talk about it. It's just 9 pages. And that's paper. I like Ehsan. Ehsan is in tune. Ehsan is the gangster. I know. No, real recognizes real. That's why I'm saying. Honestly, this is not cold enough. So let me. I put the fan on high. I guess you won't hear anything. Let's bring it low. But the fan on. Okay. At least I need some. Yeah, why can't I? That's better. Guys, I'm smart. I can say that. I'm pretty smart. Is it getting out of that shit? Alright. Ah. It's like here. The cold weather comes here. I need to Make it go towards me more. Yeah. I'm gonna close it. Yeah, that's better. That's what I want. And also, that's by the way so stupid. This, they do not put a lever or something handle to set this direction. The dumbest fuck would understand that, and it's just no cost, to be honest. It's on me. Alright, I think we did it. This one I'll better. So, what was the fucking paper? Distillation. I like the KDD paper. I will read it to you though, probably. That's okay, right? Projects, thesis, my thesis. My thesis is my business. That's it. My thesis is my business. Everything else, fuck off. I want to get my thesis done. I want to go live my life. I'm done with this shithole called MIT. Yeah, you heard it, bitch. MIT, you're a shithole. Everybody wants to leave you. He's really good, pay me good. Okay, what is this? Why am I showing this? Okay, I'm not showing anything. Right. Oh, I should go to my... I tell you something. Don't go to graduate school if they're not paying you. Wait a second. You say, oh, graduate school is like a investment. I don't want investment. Pay me cash. Yeah, pay me in cash. Investment. You are in. I know where to invest. Give me the money, I will invest myself. Well, alright. Anyways. So the thing is that we have so many things here. Okay, I know what to do now. Counterfactual. That's what we want to do. Get ready, guys. Fasten your seat belts because So counterfactual learning to rank via knowledge distillation. Again, by the way, I go to that's good. Alright, I don't need to This is not very big. I want it bigger. Anyways, I think we'll look at both of them. Fuck that. All right. Okay, counterfactual learning to rank via knowledge distillation. eBay search ranking and dude, look at this group. eBay search ranking and monetization. That's amazing. Wait a second, let's see maybe Amazon has. So there's not their research. Abstract knowledge distillation. What was distillation? The process to purify liquid to gas, separate, then condensation. Is a transfer learning technique. What was transfer learning technique? If you had a big data set, well, we need to come up with a good train a good model on it. It's called the teacher model. But our application requires faster decision making. So we are going to make a smaller data set, a smaller model, simpler model out of the teacher's model, which is called the student model. Technique to improve the performance of a student model trained on a distilled empirical risk formed by a label distribution defined. Okay, what is distilled empirical risk? I don't know. Let me make a question mark here. What is it? We can ask ChatGPT right away. What is a distilled empirical risk?
Distilled empirical risk is a concept related to machine learning and statistical learning theory. It refers to a simplified version of empirical risk that focuses on the essential aspects of the risk, removing extraneous or less impactful factors. To understand this better, Let's break it down.
So get rid of the unnecessary part.
Empirical risk is the average loss over a given set of training data. It is a measure of how well a model performs on this data. The empirical risk REMP R_EMP REMP for a given model is calculated as follows. REMP, H, equals 1n sigma I equals 1n L.
Makes sense.
11, R_EMP, H, equals \frac 1n \sum_I equals 1 caret NL, Y_I, H, X_I, REMP, H, equals N1 sigma I equals 1 NL, YH, 11. Where HHH is the hypothesis or model. NNN is the number of training examples. 11 Y, X_I, Y_I, 11 Y, are the input-output pairs in the training data. LLL is the loss function that measures the discrepancy between the predicted value H, 11, H, X_I, H, 11, and the distilled empirical risk. Distilled empirical risk involves focusing on the key elements that contribute to the empirical risk, potentially simplifying the model or the loss function to capture the most critical aspects of the data. This can be particularly useful in contexts where the full empirical risk might be too complex or where certain aspects of the data are more relevant than others. In practice, distilled empirical risk could involve techniques such as feature selection, identifying and using only the most important features of the data.
So what does that mean? Feature selection probably means removing some of the dimensions of X, or creating new dimensions by mixing some of the dimensions.
Simplified models, using simpler models that capture the main trends without overfitting to noise. Data distillation, creating a smaller, representative dataset that retains the key characteristics of the original data. The goal of distilling empirical risk is to achieve a balance between
So if the model is too complex, it gets too sensitive towards the noise. When overfitting happens, when you let your model have too many parameters, it doesn't mean that it is capturing what is happening. It just gets too much reactive to the noise, while a simple model removes those noises. Interesting. Creating a smaller representative dataset that retains the key characteristics. Data distillation, alright.
model complexity and performance, ensuring that the model is both effective and efficient.
Perfect. That was a nice answer. Alright, let's go forward. Formed by a label distribution. What is a label distribution? Well, label distribution defined by some teacher model, which is typically trained on the same task and belongs to hypothesis class with richer representational capacity. I don't know what is mathematical definition of representational capacity, but good enough. In this work, we study knowledge distillation, which means what? Simplify it, purify it, get the features that matters more in the context of counterfactual learning to rank. Counterfactual, what does counterfactual mean? We have the fact that the life is like this. Counterfactual means what if I did this, what would have happened, right? And learning to rank, rank is about ranking, learning also learning. Counterfactual probably says, if I did this, how would the ranking change? Something like that. From implicit user feedback. We also talked about explicit and implicit user feedback. Explicit one is more clear, there are not enough of it. Implicit ones, we can track users' behavior on the platform. The thing is that it has a lot of noise. Just because the user watched the show, it doesn't mean that they like it, they didn't like it. They may hated it. Or just because the user didn't watch the show, it doesn't mean they didn't like it. It means that we don't have data about it. we consider generic partial information. We talked about this stuff far more in the other paper, fundamentals of e-commerce. All right, we consider general partial information search ranking scenario. Generic, so it's generic, it's not specific, like probably by generic it means not personalized. Partial information search ranking, so it's not full information. What is a partial information ranking, search ranking? I don't know. So we have some information and we want to rank the search results. That's it. Scenario where the relevancy of the items in the logged search context is observed only in the event of an explicit user engagement. So the user searches something, right? Standing desk. And a lot of items show up, right? Are these items relevant to the user? We don't know. We only know that if we have explicit user engagement. The key idea behind using knowledge distillation in this counterfactual setup is to leverage the teacher's distilled knowledge in the form of soft predicted relevance label to help the student with more effective list-wise comparisons, variance reduction, and improved generalization behavior. So once we simplify to the student, we want generalized. Why are we using distilled knowledge? Because it's too much, but here, is it like we have too much information about ranking or something like that, and then we want to have a softer prediction? I don't know. What is distilled knowledge exactly? These are terms that just the name for mathematical terms. Hopefully they represent those mathematical terms good enough, but it doesn't make sense to get too much involved with these words definitions. An improved generalization behavior. We build empirical risk estimates that rely not only on the debiased observed user feedback, empirical risk estimate. So our model tries to minimize empirical risk or distilled empirical risk that rely not only on the debiased observed user feedback via standard inverse propensity weight. So we had this inverse propensity weighting, which was a metric for ranking stuff, I think. And then the data, first of all, we debias it for sure, makes sense. I don't know. Observe user feedback. User feedback means their behavior because it's implicit. Why a standard inverse propensity weight? IPW.
Distilled empirical risk is a concept related to machine learning and statistical learning theory. It refers to a simplified version of empirical risk that focuses IPW stands for inverse probability weighting. It is a statistical technique used primarily in the context of causal inference and observational studies to adjust for selection bias and confounding variables. Here's a detailed explanation of how it works. Inverse probability weighting, IPW. Inverse propensity weighting, IPW, is a technique used to address confounding in observational studies, particularly when estimating causal effects. It involves weighting individuals by the inverse of their propensity score, which balances the distribution of covariates between treatment groups, making the comparison more like a randomized.
It involves weighting individuals by the inverse of their propensity score. What is a propensity score? which balances the distribution of covariates between treatment groups, making the random. Treatment groups is that you experiment the treatment and then see what happens to that group, right?
Controlled trial. Steps in inverse propensity weighting. Estimate propensity scores. The propensity score is the probability of receiving the treatment given a set of observed covariates. This can be estimated using a logistic
propensity score is a probability that once you met a set of covariates, you will receive the treatment.
Model where the treatment assignment is the dependent variable and the covariates are the independent variables. Propensity score E, sheet, E, X underscore I, E, sheet, for individual 3, E, X underscore I, equals P.
So, propensity score is the probability of receiving treatment given the covariance, alright? Treatment indicator, 1 if treated, 0 if not, and Xi are the covariance. Calculating the weights. So it is the inverse inverse propensity probability score is 1 over it, right? Calculate, it's 1 over it or 1 over 1 minus. So it is 1 over P of Ti equals 1 given X, alright. Well, you defined it as above, then we didn't need to have the multi-formula. For treated individuals, the weight is the inverse of the propensity score. For untreated individuals, the weight is the inverse of the 1 minus 1. Weight are as this, applied weights in analysis. So what is it? What is this weighting? If the probability of you receiving your treatment, probability of receiving treatment because of some of the data set, like your features, X's are covariates, but I think they're features, right? Is high, 1 over 8, it means that if you have these features, you get treated with high probability, right? So why should we make it smaller by reversing it? Well, it kind of balances, right? That was the whole point, that we want to balance the situation. If because of your covariates or because of your features, you're receiving a lot of treatments, we want to kind of balance the society, the data points we have, so we treat you the propensity. Your weight will be less, something like that. Regression models or other weighted statistical.
Equals P, T underscore I equals 1. Consider a study investigating the effect of a new medication on patient outcomes, using data where patients chose whether or not to take the medication. Estimate propensity scores. Fit a logistic regression model where the dependent variable is whether the patient took the medication, and the independent variables are patient characteristics, example age, gender, health status. Calculate weights. For each patient, calculate the propensity score from the logistic regression model. Calculate the weights based on the propensity scores. Weighted analysis. Perform a weighted regression analysis to estimate the effect of the medication on patient outcomes, using the calculated weights. Advantages of IPW. Reduces confounding. By balancing covariates, IPW helps to reduce bias due to confounding variables. Causal inference. Facilitates the estimation of causal effects in observational studies. Flexibility. Can be used with a variety of outcome models and study designs. Limitations of IPW. Model dependence. Requires correct specification of the propensity score model. Misspecification can lead to biased estimates. Extreme weights. If some propensity scores are very close to 0 or 1, the core weights can be very large, leading to instability in the estimates. Trimming or stabilizing weights can sometimes mitigate this issue. Overlap assumption assumes sufficient overlap in covariate distribution.
I like that we can reply. But okay, I want to specify to reach here. Okay.
ChatGPT 408 is a distilled empirical risk. ChatGPT distilled empirical risk is a limitations of IPW. Model dependence requires correct specification of the propensity score model. Misspecification can lead to biased estimates. Extreme weights. If some propensity scores are very close to 0 or 1, the corresponding weights can be very large, leading to instability in the estimates. Trimming or stabilizing weights can sometimes mitigate this issue. Overlap assumption assumes sufficient overlap in covariate distributions between treatment groups, meaning every individual has a non-zero probability of receiving either treatment. Inverse propensity weighting is a robust tool for addressing confounding in observational studies, helping to approximate the conditions of a randomized experiment by creating a pseudo-population where treatment assignment is independent of observed covariates.
Perfect. Let's go back to our paper. More effective, least wise comparisons, variance reduction. We also conduct rigorous counterfactual offline evaluation. It should be offline because counterfactual doesn't happen. So the data will be synthesized. Evaluation as well as online controlled randomized experiments for a product search ranking task in a major e-commerce platform, which is eBay. Dude, you have eBay here. Why do you say in a major? The primary distinction of the proposed distillation-based perspective in contrast to a standard counterfactual. Why are we? Okay. He's talking why are we using distillation? Standard counterfactual inference based on potential outcome modeling is that we leverage teachers trained on different yet related tasks. Teachers trained the model on yet related tasks, different yet related tasks to improve the generalization power of a student model for a ranking task. So we always have the ranking task, right? The goal is how to rank the products as the platform. Specifically, we report strong empirical results showing that the distilled knowledge from a teacher trained on expert judgments can significantly improve the generalization performance of a student ranker. Report strong empirical results. I love empirical. Show me empirical. That's it. Fuck theoretical. Showing that the distilled knowledge from a teacher trained on expert judgments. What is expert judgments? Can significantly improve the generalization performance of a student ranking. So it helps the ranking. We also show how explanatory clique models, alright, trained for a clique prediction task, explanatory clique models trained for a clique prediction task with privileged encoding of the presentation context in observational data can explain away. Why is explain away in italic? I don't get it. Explain away is a mathematical term. The effect of presentation related confounding for learning to rank models. Okay, I didn't get this. Let's break it into smaller points. Okay, first of all, they have empirical results. And showing that the distilled approach will improve the results. What is an expert judgment? Oh, expert judgment is like probably oh, okay. Expert judgment, probably they are the expert judgments, right? Wait, I love it actually. You know what? I fucking love it. Somebody says, I'm an expert, and I think that's good. Fuck you, mathematics. I don't have a proof, but I'm expert. I do my job, and you are no shit, math. Right? I love it. If it means that, okay, judgment of a person who is expert. Well, that means like experts judgment. An expert's judgment, but they're saying another term. So, sometimes probably these Italian terms are terms that do not have a mathematical definition, which is good. I love it. Mathematics is too restrictive. Yeah, individuals. Yes, this is how knowledge works. Mathematics is our tool. We are not
expert judgments refer to the insights, opinions, and evaluations provided by individuals with specialized knowledge or experience in a particular field.
Perfect, that's
These judgments are often used in various domains.
That's it, that's what we want. Dude, I love to work with ESA. Strong empirical results showing that the distilled knowledge from a teacher, okay, can significantly improve the generalization performance of a student ranker. What it means is that, motherfucker, the result looks good. I don't have an objective function to show you that, oh, okay, we did this and it's better. No, but we did it and it showed up being better. We also show how explanatory, I don't know how to pronounce this shit. I say explanatory. Notorious. Explanatory. Explanatory. Doesn't matter, to be honest. Explanatory. Serving to explain something. Clique models. Well, we have the clique models. What is the clique model? By the way, explanatory clique model is also in what is the clique model? Clique model says whatever is at the top of the list, they will be clicked more. That's it, right? Show how explanatory clique models trained for a clique prediction task with of the representation in the observation can explain away the effect of. I need to email somebody very fast. Okay. Perspective is in contrary. That's the click model, I guess. Prove the generalization performance of a student ranker. We also show how okay, so by the way, we don't need to read this paper completely, right? We need to, I want to get to know the space that Ehsan is working, which is the space I want to work. So this special thing that we have a teacher model, student model may not be exactly what I want to know. But it has terms like counterfactual, it has distilled knowledge, probably distilled knowledge. It is about e-commerce, it is about learning to rank, so it can be very useful. Show how explanatory click models trained for a click prediction task with a privileged encoding of the presentation. Explain away. What does explain away mean? The effect of presentation related confounding of the LTR model. What is a confounding? What is a confounder? Confounder is something used in causal inference. Confounding. Critical concept. Ooh. Don't escape.
Confounding is a critical concept in statistics, epidemiology, and research design that refers to a situation where the effect of the primary exposure or treatment on an outcome is mixed up with the effect of another variable.
So we have two.
This other variable, known as a confounder, is associated with both the exposure and the outcome, potentially leading to biased estimates and incorrect conclusions. Key points about confounding. Definition. A confounder is a variable that influences both the dependent variable, outcome, and the independent variable, exposure or treatment, causing a spurious association between the exposure and the outcome. Bias. Confounding can lead to bias in estimating the causal effect of the exposure on the outcome because the observed association may be partially or entirely due to the confounder. Example scenario. Imagine a study investigating the relationship between physical activity, exposure, and heart disease, outcome. Suppose age is a confounder because it is associated with both physical activity, older individuals might be less active, and heart disease, risk increases with age. If age is not accounted for, the study might incorrectly estimate the effect of physical activity on heart disease. Identifying confounders. To identify potential confounders, researchers typically look for variables that are associated with the exposure. There is a statistical relationship between the confounder and the exposure. Associated with the outcome, the confounder independently affects the outcome. Not on the causal pathway, the confounder is not an intermediate step in the causal pathway from the exposure to the outcome. Methods to control confounding. Study design. Randomization. Randomly assigning participants to different treatment groups helps ensure that confounders are evenly distributed across groups, reducing their potential impact. Restriction. Limiting the study to individuals with certain characteristics can control for confounding. Example, studying only non-smokers to control for smoking as a confounder. Matching. Pairing individuals in the treatment and control groups with similar values of the confounders, example matching by age and gender. Statistical methods. Stratification, analyzing the data within strata, subgroups, defined by levels of the confounder, example analyzing the effect of physical activity on heart disease within different age groups. Multivariable adjustment, using statistical models, such as multiple regression, to adjust for the confounders by including them as covariates in the model. Propensity score methods, estimating the probability of treatment assignment based on confounders and using these scores to adjust for confounding through matching, stratification, or weighting, example inverse probability weighting. Example of statistical adjustment. In a study examining the effect of a new drug on blood pressure, Suppose smoking status is a confounder because it is associated with both drug use and blood pressure. To control for this confounder using multivariable adjustment, you might use a regression model like this. Blood pressure equals beta 0 plus beta 1, drug, plus beta 2, smoking, plus backslash text blood pressure equals backslash beta underscore 0 plus backslash beta underscore 1 backslash text, drug, plus backslash beta underscore.
Regression model like this, blood pressure. It is funny, how can they read the latex part, because it should not be that difficult for them. Blood pressure, beta 0 plus beta 1, drug, beta 2 excellent. Beta 1 estimates the effect of the drug on blood pressure, adjusts for smoking status. Beta 2 accounts for the effect of smoking. Consequences of, I don't know why beta 1 is related to smoking. Not addressing confounding. Failure to properly address confounding can lead to biased estimates. Wait a second, by the way, when is it? When is good to smoke cigar? Celebratory events. No, that I don't mean that. Oh yeah, whenever you want to do that. Social gathering, relaxation and personal. Guidelines for enjoying a cigar. Choosing the right environment, setting matters. Okay. Pairing a cigar with a complimentary drink. Whiskey. That's really good. Yeah, I think if you smoke, you should smoke the right way. Ensure you have time to enjoy. Yeah. Wow. Oh, it's okay. They're big cigars. All right. Right, these are the bad things. What are the benefits of health benefits of smoking cigar? No benefits. That makes you a liar. There should be benefits. Yes, there are risks. What are the benefits? Relaxation, social bonding, enjoyment and sensory pleasure, cultural and health risk for that. Anyways, so we know what is confounding. Confounding is an variable that affects other variables in a causal manner, and we have to look for it. We also show how explanatory clique models trained for a click prediction task with privileged encoding of the presentation context and observational data can explain away the effect of explain away. I think it's, we want to remove the effect of confounding, right? Anyways, why did they start this shit? Look at this, how short of this motivation. That's good. You want to write a paper, address a simple problem, and done. Another problem in the next paper. Okay, abstract took us 50 minutes. We will, by the way, abstract is the most important part. We got to know what they are saying. So now we can play some counter to counterfactual, counter strike. Everything is counter here. Counter example, counter explanatory, and then we will read the motivation. The next parts, like I try to not get into the mathematics as much as possible, but if it is necessary to understand, I am happy. If mathematics is a necessity, I love it. If it is extra, that is called mental masturbation. Remember, I'm an engineer, I'm at MIT, but not at the fucking mathematics department. I'm at an engineering department. So what I care about is solving the problem at the end of the day. Let's go. I am an engineer. I am an engineer. I am an engineer. I am an engineer. I love engineering. 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 I am an engineer. I am an engineer. I am an engineer. I am an engineer. How could I kill it with one? Oh, dude. Who is hitting me? Oh, fuck. Fucking monkey. I am an engineer. I don't care if you do care. Let's go over there. Mathematics is not my goal, but it is just a tool. Mathematics. Dude, I killed him first. I'm a fucking engineer slash gangster. Oh, fuck. Yeah, this fucking song doesn't wipe with. I'm just getting killed here. Guy with a machine. When a guy with a machine gun kills you, it's not good for him. What am I doing? It's fuck being an engineer. I'm a serial killer, dude. I'm here to kill. I'm a multifaceted person. Who killed you? Nash. Nash killed me. That's my life story. Oh shit. Damn, he had a machine gun. I'm not doing good, guys. I'm not lying. One. Nash again. Fucking John Nash. Dumb fuck. Ah, dude. Monkey killing me left and right. That's why I hate monkeys, by the way. Nash monkey. Monkey Nash. Nash was a monkey. Oh. Why am I getting died? Dude, come on. Okay. Wow, three of us, we lost. That was so bad. Guys, I need some comp. Oh shoot, damn. Who is this guy? Somebody come with me. That's it. Here are just two people. Nash monkey. Is that good? Good. Dude, why doesn't my gun kill? That's it. I am killing. Wow, Nash was even worse than me. Who could have lived? Their top killer didn't even touch me. I was so bad. Why did he disappear? Again, you disgusting piece of shit. Fuck, monkey got the... Anyway, oh my god, that was so mean. Stupid. Dude, don't forget that this is another kind of venue. Oh, shut. Shut your mouth up. I was not even killed by him. Oh fuck, dude. What? Okay, I got my gun. Oh fuck, dude. Okay, our team is back, guys. Oh shoot. Who shot me? How did they do that? Damn, they are getting better and better. Oh! Dude, they got to the pistol. That's stupid. They will knife up. Headshot? Oh my god. Yeah. Dude, why can't I kill? They kill. It's funny. I am so fucking scared. What is happening? He's following my guy? Oh fuck, dude. One time I'm my third gun. Come on, guys. Okay, I'm playing the game back. I'm not playing right. Fucking monkey, come here, monkey. Ha 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 ha. You're a donkey, monkey. I killed. How did you do that? Fuck. Why are they bitter? Oh, who killed us there? Shit, he had it. I had him. Okay. I'm just stressed. I need to be calm. That's what I need. Fuck. How did he know that I will... Oh shoot, he killed me? Dude, I like that they slide when they shoot, so I need to learn that shit. Oh, he's killing me all the time. What is that? What is that? Okay, then enemy right there. In the center. They kill us too much, so I try not to get exposed. I'm gonna adjust my strategy a bit. Oh, dude. Oh, shoot. Like, that's our best spot, and they are killing us right and left there. Did you see that? He just walked into me and killed me. Oh, fuck, man. Where is he? Okay, we are weaker, guys. We need to understand that. Get it? Yeah, get it, play chill, let them attack and kill them. Oh shoot, that motherfucker had me. Alright. Hopefully my friends get me. They are coming toward us. Dude, my gun was better. How could you kill me? Oh shit. Yeah, don't rush it. Let them come. Let them come. Seems they are better. Okay. Yeah, let them come. Damn, how is he so good? Ooh, don't kill me, yo! How does he shoot? I think I had this real noob before. Ooh, where? These are trees. They are strong, dude, but didn't expect it from the beginning. Why is that guy having a warning or sign or like alarm sign? What is happening there? I want to know what's happening. Oh shoot. Ah, shoot. Who got the knife? They were far better. Like, they were far better. The whole team, their whole team, their whole team was above us. So I say, their whole team was above us, and I say it needed to be balanced.